It worked right yesterday, so I'm hoping it works right today. I think we're official. Okay.
We're here, we're live. Hello.
So, like I said, the last 2 days, we've been reviewing how to factor quadratics, quadratic trinomials, quadratic differences of two squares, quadratic four terms, right? All sorts of stuff like that. We're learning how to factor all those. And then yesterday we remembered practicing how to find the zeros, find where they cross the x-axis, where a parabola crosses the x-axis. Okay. So now we're going to talk about a real life situation. Okay. Just to begin, it's just sort of an introduction to how you might use parabolas in real life. And there's an amazing formula called the vertical motion model. Before I actually write that formula, I want to talk about the quadratic, a typical quadratic equation, which would be like this: y equals ax squared plus bx plus c. All right, that is a standard quadratic formula. That's an equation that is, the a is usually a number, the b is a number, and the c is a number. We have the y and the x squared, and the x stays as y and x squared. If we talked about this briefly during a game about a month ago. If a is positive, if the number in front of the x squared is positive, he has a nice happy face, right? So if you were going to graph a parabola, it would be a smiley parabola, right? Because positive thoughts make you feel really happy, right? And if it's a negative, it would be a very sad face, right? It would be a parabola like this, right? Now I'm going to write the vertical motion model, and we're going to just sort of see what it looks like, and then we're going to talk about the terms. So h equals negative 16 t squared plus vt plus s.
Ooh, getting fancy up in here.
Okay? So write that down in your notes. Really important formula. For me, like when I was younger, and actually even now, I find, like when I think of people like Einstein and all these great scientists that are able to come up with equations to define our world, define actually what's happening in our world, I think it's amazing. And that is an equation. That is an example of an equation that helps to define something very, very real in our life. And you're going to see in just a second. I mean, there are kind of puny examples, but they're the beginnings of understanding how quadratic equations can be used in real life. So first of all, we've got to talk about all these letters and what they stand for. Now, instead of y, they're calling it an h. So think about it. If you have a graph, we'll just put this over here for a second. The y-axis is now our h-axis. Okay? H, let's see. H is the height. I think I can do it here. Yes, okay. H is the height. I can't write lowercase, so I can't. H is the height at any given time. Okay? T, now notice, look, t squared x squared, tx. T is now, our x is now our t. So our x-axis is now our t-axis. T stands for time. Okay? And it's the time in seconds. that an object is in the air. T is the time in seconds that an object is in the air. You'll find that with graphing, oftentimes when you're dealing with time, the time is going to be the x-axis. Okay? So always when you think of time, if time's part of the phenomenon, it's always going to be on the x-axis. V. V is the initial vertical velocity in feet per second. The initial vertical velocity in feet per second. So it's how fast you're moving upwards vertically. Okay? S. Look like an S. I don't like S because it looks like a 5, but hopefully that doesn't look like a 5. Okay, S is the initial height in feet. And I like to think of it, since it's an S, it's really the starting height. I think that's all of them, right? 1, 2, 3, 4. Yes. 1, 2, 3, 4. All right. So let's just think about it for 1 second. I know that my height, the height that I'm at, if I jump off the ground, I have a vertical velocity. I have a velocity as soon as I leave the ground, right? There's a vertical, boy, that was really high, right? But vertical velocity, there's a vertical velocity, initial velocity. But is it going to be constant for the entire time that I'm in the air? No, what happens? I start going up and then what happens? I stop at some point and I start coming down again. Why? Gravity. Gravity. This formula is taking into consideration gravity. Your minus 16 is helping with that. That's taking into consideration gravity. So I need to know what my initial vertical velocity is, and then I need to know where I start. How high do I start? Am I starting? If I'm starting on the ground, which I am, and I'm jumping off, my starting point, my initial height is that's what S is. The initial height, or the starting height, is 0, because I'm at y is equal to 0. I'm on the ground floor, right? And I jump up, and then I land back on the floor again, right? So now the thing that I don't know is my time. At time 0, I'm on the ground, but at like a half a second, I'm up in the air somewhere, right? So what's happening? Let's think about it. If I jump, I'm starting here. Okay? I'm starting here at 0, 0. My x-axis is basically the floor. It's like the ground. Okay? This is my height. So I'm at height of 0 at when the time is 0, when I haven't started yet, I'm on the ground. Therefore my height is 0. Right? And my time is 0. As soon as I jump, suddenly the time starts clicking. So even though I'm going straight up and straight down, because you think that you graph it like this, you go up and then straight down. But because it's based on time, as I go up, the time starts clicking. So I actually have to move it over. You know what I'm saying? As I'm going to go, if I jump up like 2 feet, right? By the time I get up 2 feet, the time is already over here, so I'm going to be over here. And and then after 2 seconds I might be here. Here, and then maybe that's when I start to fall again. So the question is, when do I hit the ground again? How many seconds will it take me to hit the ground? That's the kind of problem we're going to be working on. It is a parabola, right? Oops, sorry, it's starting at 0. It's a parabola. It starts at ground level at 0, and I land again at the x-axis 0. So I'm asking, with a word problem, if I do that, and I give you the initial vertical velocity, and I give you the initial starting height, then all you have, you're going to have an equation that just has an h. The only unknowns are going to be the h and the t's. Does that make sense? So the question is, how many seconds? After how many seconds will I land on the ground? So after how many seconds will I land on the ground? What will be my final height when I land on the ground? 0, right? So I could set my y, or my h, equal to 0. And then I'm going to be solving for x, or for t in this case. I'm going to find my zeros. I'm going to be finding my zeros. That's why I'm setting the h equal to 0. I'm finding my zeros. I'm finding when I cross the x-axis. Does that make sense? The ground is my x-axis. I start, I jump up in the air. I know how fast I'm jumping initially. And I know, then I can figure out how long it's going to take me to land again. So now we're going to do an example. Can I erase all this stuff? This stuff at least? I don't think I explained that all very well, but hopefully you got the idea. I think once you see a problem, it won't be quite so hard. Okay, I'm going to use the first one on this homework, so you won't have to do it. A startled, to write this down, startled in your notes, armadillo, jumps straight in the air.
That's right.
With an initial vertical velocity of 14 feet per second. After how many seconds does it land on the ground? All right, so that's the question. Well, that's the problem. Everybody have finished writing it now? Okay, so let's just fill in the blanks. So first of all, I'm going to write my equation. H is equal to negative 16t squared plus Vt plus S. Okay, in this, what did they give me? Okay, which is what? 14 feet per second. So I can replace this V with 14 feet per second. So H is equal to negative 16t squared plus 14t plus, what's my S? My initial starting 0, right? Because it's pretty likely he was on the ground. It doesn't say, so I'm assuming he was on the ground since he's landing back on the ground again, right? And when he jumps straight in the air, if he's going to land on the ground, he must have started from the ground, right? So yeah, so that's going to be 0, right? So I really don't even need that. I could actually just erase that because 0 is nothing, right? Are you agree with me? I don't need that. Here's my marker. All right. Now let's. So that's our equation. It makes sense that it's negative 16. That what kind of a parabola? It's a sad face parabola. Most often when you're dealing with gravity, it's going to be a sad face parabola, right? You're going to go up in the air and then you're going to come back down again, right? So it's going to be a sad face parabola. That makes sense. Now let's see. So that's our equation. Now let's see what they ask. After how many seconds does it land? In other words, find t when it lands on the ground, when h is what? When h is 0. So they're saying find the zeros. That's what they're saying. Find the zeros. And we all know how to find the zeros. We set this equal to 0. Right? So I'm going to say 0 is equal to negative 16t squared plus 14t. Now, when I ask you to find the zeros, what do you have to do to the stuff? What do you have to do to it? To find zeros. So on all the problems I've given you, what did you have to do to find the zeros? I gave you a quadratic expression equaling 0. What did you do with that quadratic expression? Yes, factored it, right? You factored it. Okay, so now we've got to factor this. How do you factor it? What's the cardinal rule of factoring? The first thing we try to factor first. Greatest common factor. What is the greatest common factor?
It's no, what? No, 2.
Say, what is it?
2.
2 and what? 2 and what?
T.
2t, right? Because they both have t's in it, right? So here we go. We got 0 is equal to, we said 2t,
So negative what?
and then what do we have? We got negative 8t plus 7. Am I right?
Yeah.
Okay. Now what do we do now?
Now they're going to
If a times b equals 0, then either a equals 0 or b equals 0. So we have our two factors. We have 2t equals, we have either 2t equals 0 or negative 8t plus 7 equals 0. So I'm going to write that out. So either 2t equals 0 or negative 8t plus 7 equals 0. Right? So I'm going to divide by 2, divide by 2. I've got t is equal to 0. I'm going to subtract 7. I've got negative 8t is equal to negative 7. Divide by negative 8. Divide by negative 8. T is equal to 7/8 of a second. All right. So we have two answers. Does that make sense so far? It really isn't that hard.
You mean we're not done?
Well, we have two answers. Well, let's look at the question. It says, after how many seconds does it land on the ground? Which one can it not be?
0. So
It can't be 0. That's what it was. That was what it was just before I jumped, or before he jumped, right? It can't be 0, so it's got to be this one. Does it make sense? So with quadratic, when you solve for zeros in real life situations, one of them is going to be correct. And you've got to use logic to figure out which one. It can't possibly be 0 because you already jumped in the air. There's time. Time is clicking, right? The clock is moving. So it can't be 0. It's got to be above 0. So it's going to be 7/8 of a second. Okay? Does that make sense? Yeah? Okay. Sometimes the s will not be 0. Like, let's say somebody was on a log that was 2 feet off the ground, and they jumped up. They had an initial vertical velocity, but they also were jumping outward. But they were still going up, right? So they were actually jumping in a parabola. And they're leaving from here, but they land here. So then it would be +2, or plus whatever the initial starting height is. See what I'm saying? and you would still have a quadratic. In that case, you'd have a quadratic trinomial, and you would have to factor that trinomial. That make sense? All right, well, that's basically it. I think one example is enough. Do you agree?
Yeah.
And then I'll let you guys work on the homework right now. Okay, so that's it for the lecture.